Hi friends, welcome to VTeach. Now I am going to start the subject Signals and Systems, which is the basic subject of communications. So actually in our ECE, there is a electronics part and communications part. And Signals and Systems is the basic subject for that communications part. And as you know, signal is nothing but one type of variation or one type of different pattern in order to communicate. For example, let us say drum sound. So drum sound can make the sense where we are having. So like that, when you take fire signal, that fire signal will communicate where that person. And based on the different signals, that may be sound or that may be fire or that may be some person or that may be some anything. So whatever the pattern, whatever the variation that consisting certain amount of information is nothing but called signal. So here we will start from unit 1, which is signal analysis. And within the signal analysis, we need to know what is signal and what is system and what are the different classifications and what are the particular characteristics of the signal, and is there any analogy factor for the signal in order to understand in the better way, and what that factor will describe the nature of the signal. So all those things we need to see in this unit 1, which is signal analysis. Now let us start the first topic, definition of signal and system. So here basically the signal is nothing but the physical phenomena, which is nothing but a function of one or more independent variables that conveys the information. So here independent variable and dependent variable. So everyone knows about the dependent and independent variable in the functional relation. For example, if you call any function, let us say y, which is a function of x, let us say the expression ax square plus bx plus c. So in this y is dependent variable and x is independent variable. So here by taking that independent variable value, for example, if I consider this independent variable x as a real variable that can take any value from minus infinity to infinity. So by taking that independent variable value, you will get certain value for the y, which is the function of x. And this y is nothing but called the dependent variable, which depends on the values of x. So here signal is nothing but a function, and there is some difference between the function and the signal. So basically function means that may be single valued function or multi-valued function. Let me explain with some example. Let us say here y equal to root x, that is the function. Now let us say for x equal to 25. Now what is the value of y? Which is root 25, and its value is, yes, either plus 5 or minus 5. So for the single value of x, we are having y value either plus 5 or minus 5. That's why here y is known as multi-valued function. Why? Because for single value of x, there are the multiple values. And if I said y equal to x square, now for x value, let us say 25, then y is 25 square, which is 625. So there is a single value for the any x value in this function. That's why here we can call this y equal to x square as a single valued function. So here function means that may be either single valued function or multi-valued function. But signal is always a single valued function. So remember that point. So signal is nothing but a function which is the function of one or more independent variables. Those independent variables may be time, distance, pressure, temperature, whatever it is. So it is the function of more than or equal to one independent random variable that conveys certain amount of information. So here conveying means that functional representation is not representing the content, whatever the message in that signal. So there are certain variations within that. that pattern or that change and that variations conveys certain amount of information. So here whatever the signal, let us see the definition. It is a physical phenomena and it is a function of one or more independent variables that conveys the information based on the nature of physical phenomena. Now let us see some real life examples for the signal. If you say the heartbeat signal, what it explains, you know. Based on the heartbeat signal, the doctor can diagnose what the patient. And similarly, let us say another example, weather forecast signal. So based on that weather forecast report, we can decide whether we have to go out or we have to stay inside the home. Whether that particular thing is natural or that happens good to go out, we can move out. Or otherwise, if there is heavy rain, at that time we have to take umbrella to go out. So like that, based on the weather forecast report, we can have certain information whether how to go out or not, or whatever the application, whether how to go for the fishes or not. So like those. So whatever the thing, based on the weather forecast report, we can decide. So these are certain real life examples for the signal. Heartbeat signal, weather forecast and so on. And similarly, here system is nothing but the set of elements or maybe the set of certain functional blocks which are interconnected together to process the applied input signal to get the required or desired response. So here system will make certain processing. For example, let us say education system. So our college is producing nearly certain number of BTech students. So actually intermediate students are coming, and after 4 years processing in that college, we are having BTech degree. So like that, we have particular system, whatever that system, that may be a set of elements or the interconnection of certain number of blocks which are required to produce the required response from the given input signal. So here the definition of system is nothing but a set of elements or functional blocks that are connected together and produces an output in response to an input signal. And generally that system is represented by the block diagrammic form, and within that block we have to mention whatever the transforming operation we are performing with by some letter either H or T. So here T is indicated in this figure, and on the left side what are the signals we are giving. Let us say here single number of input or maybe multiple number of inputs are also for the system. So let us consider here single input, so one input signal, and it is producing one output signal, which is output is represented at the right side of that particular block. And we can say certain examples for the system: attenuator, TV, amplifier. So in real life we can say whatever the particular set of rules which are used to process the particular thing in order to get the particular required thing. So those all are examples for the systems. Thank you.